This is Rake. Welcome to DevOps Nexus channel. Today, we are tackling an absolute beast of a topic, but honestly, it's one that is guaranteed to be a massive part of your AWS Certified Cloud Practitioner exam. We're talking about AWS Compute Services, which makes up a huge chunk of Domain 3. Now, if you kind of think of your AWS environment as a living, breathing organism, well, compute services are its brain. This is where the thinking happens, right? It's where the data is processed and where your actual application code gets executed. Instead of buying and racking physical servers in some cold, noisy data center, AWS lets you spin up this brain power entirely on demand, and you pay only for exactly what you use. We're going to break all of this down to make sure you walk into that exam room with total confidence.
Okay, here's our roadmap for this explainer. 1. Foundations with EC2 and AMIs. 2. Scaling and distributing traffic. 3. Going serverless with AWS Lambda. 4. Containers, specifically ECS versus EKS. 5. Managed services and platforms. And finally, 6. CLF-C02 exam memory tricks. Let's get right into it.
Section 1. Foundations, EC2 and AMIs.
So, Amazon EC2, or Elastic Compute Cloud, is essentially your virtual server up in the cloud. It gives you full root or administrator access, meaning you are the absolute boss of this virtual machine. But how do you actually go about creating one? Well, that brings us to the Amazon Machine Image, or AMI. I want you to think of an AMI as the exact DNA blueprint for your server. You don't just ask AWS for a generic computer. No, you ask for a computer built from a very specific AMI. That blueprint contains your operating system, whether that's Amazon Linux, Ubuntu, or Windows Server, along with any pre-installed software and configurations you might need. So, the crucial takeaway here is EC2 is the house and the AMI is the architectural blueprint used to build it. Now, I want you to really lock this next part in because it's a massive exam tip. That huge 90%, that represents the potential cost savings you can score if you use Amazon EC2 spot instances. Spot instances basically allow you to bid on unused AWS computing capacity. They are incredibly cheap, literally up to 90% cheaper than standard on-demand pricing. But here is the catch that the exam absolutely wants you to know. Spot instances can be interrupted and reclaimed by AWS at any time with just a 2-minute warning. So, they're perfect for flexible batch jobs or data processing, but they are a terrible idea for a live web server. If you have a predictable, steady-state workload, you'll want reserved instances instead. Those require a 1- or 3-year commitment, but they save you up to 72%. Make sure you remember that distinction. Moving right along to Section 2, Scaling and Distributing Traffic.
Imagine this daily traffic pattern because it brilliantly illustrates the exact problem every successful application faces. In the morning, you have a nice, quiet 100 users. Your single EC2 instance is just humming along perfectly fine. But then evening hits. You launch a new product, a marketing campaign goes viral, and boom, 10,000 users are suddenly flooding your site. If you only have that one single server, your application is going to crash hard. Your customers will get error pages, and you are going to lose revenue. Then, by late night, traffic drops right back down to 100 users. If you had manually provisioned enough servers to handle that evening rush, you're now paying for massive idle capacity, while everyone is sound asleep.
And this is exactly where our hero enters the picture, Amazon EC2 Autoscaling. Autoscaling completely automates the process of adding or removing EC2 instances based on your real-time application demand. When those 10,000 users hit in the evening, autoscaling dynamically launches new instances to share that heavy load. And when the users go to sleep, it automatically terminates those extra instances to save you money. Absolutely no manual intervention required. This gives you high availability, fault tolerance, and really crucial cost optimization. But here's the thing. Having multiple servers means you need a way to distribute all that incoming traffic evenly across them. So you have two main types of load balancers you really need to know for the exam. First up is the Application Load Balancer, or ALB. This operates at layer 7. If you see keywords in your exam like HTTP, HTTPS, or path-based routing, for example, sending traffic to /images or /video differently, ALB is your answer. It's the best choice for web applications. Then, we have the Network Load Balancer, or NLB. This operates at layer 4. If the exam asks how to handle millions of requests per second with ultra-low latency using TCP or UDP protocols, NLB is the undeniable choice.
Okay, Section 3. Going serverless with AWS Lambda.
So AWS Lambda is pretty much the ultimate serverless compute service. You literally just upload your code and AWS runs it automatically. Think about a beautifully simple event-driven workflow like this. Step 1, a user uploads an image to an Amazon S3 bucket. Step 2, that upload event instantly triggers your Lambda function. Step 3, your code executes, perfectly resizing the image. And step 4, the new image is saved to a different bucket. Notice what is entirely missing from this entire process: servers. You didn't have to patch an OS, you didn't configure auto-scaling, and you didn't provision a load balancer. The whole shebang is entirely event-driven.
And these exact benefits are what makes Lambda so powerful, and honestly, so highly testable on the CLF-C02. First off, there's absolutely zero server management. Second, it has automatic scaling built right in by default. If 1,000 images are uploaded at the exact same time, Lambda seamlessly runs 1,000 concurrent executions. Third, and this is a vital billing benefit to remember, you pay only when your code runs. You're charged based on the number of requests, the memory you allocate, and the exact execution duration in milliseconds. If your code isn't actively running, you pay $0 for compute. And lastly, it's highly available by design.
Section 4. Containers, ECS versus EKS.
Now, AWS gives you a native orchestration service called Amazon Elastic Container Service, or ECS, to manage Docker containers. But when you create a task in ECS, you actually have a major architectural choice to make. You can choose the EC2 launch type, which means you are still completely in charge of managing, patching, and scaling the underlying EC2 virtual machines that actually hold your containers. Or you can choose the Fargate launch type. Lock this word into your mind for the exam: Fargate. Fargate is the serverless compute engine for containers. You don't manage any servers at all. You just specify the CPU and memory your container needs, and AWS handles all the underlying infrastructure.
Now, you might be wondering, okay, what about EKS? Well, let's break it down so you can nail those multiple choice questions. ECS is AWS native. It's way easier to set up, it integrates flawlessly with other AWS services, and it has a much lower learning curve. EKS, on the other hand, stands for Elastic Kubernetes Service. Kubernetes is an open-source, industry-standard system. It is significantly more complex, but if a question mentions a company that is already using Kubernetes on premises, or they want highly portable applications to avoid vendor lock-in, EKS is absolutely the right answer, for sure.
Let's move into Section 5, Managed Services and Platforms. To really understand these services, we first need to get a handle on PaaS, or Platform as a Service. In a PaaS model, you as the developer simply upload your application code. Maybe it's Java, Python, PHP, whatever. The provider, which in this case is AWS, takes that code and entirely automates the provisioning of the underlying architecture. It automatically sets up the EC2 instances, the Elastic Load Balancers, the auto-scaling groups, and the monitoring. The definitive AWS service that provides this PaaS experience is AWS Elastic Beanstalk. It is the ideal exam answer anytime you see a scenario about a developer who just wants quick deployment without dealing with any manual infrastructure configuration.
Another incredible managed service is AWS App Runner, which basically automates this entire deployment workflow for you. App Runner is fully managed and specifically designed for deploying web applications and APIs directly from source code. You literally just point it at your GitHub repository. From there, App Runner takes over, automatically building the container image, deploying it with built-in load balancing and HTTPS, and finally handing you a live, fully functional public URL. It completely removes all the heavy lifting of continuous deployment.
But what if you aren't some enterprise-level developer? What if you're a beginner just wanting to host a simple WordPress blog? Well, that's where this comparison becomes really important. EC2, as we know, is advanced, highly configurable, and charges pay-as-you-go, which makes it perfect for enterprise workloads. But we also have Amazon Lightsail. Lightsail is the simplified cloud platform. It is exceptionally beginner-friendly and features a fixed, predictable monthly pricing model. So if an exam question mentions a small business needing a simple virtual private server, or VPS, with predictable costs, do not choose EC2. Hit the nail on the head and choose Lightsail.
Finally, Section 6, CLF-02 Exam Memory Tricks. Get ready to lock these in.
Okay, let's rapid fire through these essential keywords. When you see EC2 on the exam, instantly think virtual server in the cloud. When you see auto-scaling, your brain should immediately jump to automatically adds or removes instances based on demand. For ELB, or Elastic Load Balancer, the keyword is simply distributes traffic. If they ask you about serverless code execution or functions where you pay only when the code actually runs, that is Lambda. And if the question is about running AWS native Docker containers, you lock in ECS.
Continuing our memory trick list,
EKS is always your answer for managed Kubernetes. Elastic Beanstalk is your classic platform as a service. Just look for the phrase upload code and AWS manages infrastructure. AWS Batch is exactly what it sounds like. It provisions compute for heavy batch processing jobs, like video rendering or massive scientific simulations. App Runner is the fully managed service used to deploy web apps and APIs directly from source code easily. And finally, Lightsail is your beginner-friendly VPS with fixed monthly pricing. If you memorize these word associations, you are going to absolutely fly through the compute questions on your test.
So as we wrap up this explainer, I want to leave you with a bit of a provocative question to consider for your own projects. Now that you know the full AWS Compute menu, are you still overpaying for an always-on EC2 instance when a simple event-driven Lambda function could do the exact same job for just pennies? Cloud architecture is all about using the right tool for the right workload. Keep studying, keep optimizing, and best of luck on your CLF-C02 exam. Keep building smart.